All right. So we made it. So hopefully you found Canvas. I was able to get in Monday afternoon finally. Um, Very kind of our IT folks not to tell us this was some sort of cyber incident until, more than 24 hours later. But sure, they probably had reasons, right? Um, okay. Just another reason I'm glad I'm not in cybersecurity. That was probably a pretty rough couple days for folks. So you don't take down the network lightly, the day before classes start for thousands of people. So I'm sure they're all having a pretty bad day. So, all right. So I got a couple links out here. One, my personal website, just for fun. It'll have links for other things in case you need it. The Discord server, if you like Discord, I have it on my phone. I've got a Discord server that I run for my students. I think most people like that instead of sending emails. Not everyone does, so that's just an option for you. If you want to join there, you got to react to a couple things to get the right roles set up, but it should just work pretty well. The bot's pretty good at what it does, and it gets you into the class channel. And that's a great place to ask questions for things. I like that it's public, so that if you ask a question, everyone else sees the question and can see my answer, or someone else can answer too. Like, that's even better if someone else answers the question and not me. So it's out there. And then I do have the recording from Monday out here as well. So every day every meeting I'll upload those to YouTube or publish them to YouTube if I can get the Twitch thing figured out, and put the links out here for you. So awesome. So we've got a couple things to tackle. I don't know if you had a chance to check out the zyBooks or not here for the class. We don't actually get into much of the content, which is a little bit of a bummer, but that's okay. You'll get into more of it in CIS 200, and then go a little further, which is cool. So we really hit the first 9 chapters or so. And then there's a bunch of other things that I've marked as optional. I could hide them too, but that seems silly. Like, you paid for the content. So it's marked as optional. There's no points for doing it. As part of that zyBook score right at the end, I'm just going to run the report and it'll tell me how much of the first 9 chapters you did as we went along. I did want to tell you about the Zy Labs. Now that I've got decent internet access here, there's some basic things we do with Zy Labs. I haven't opened all of them yet. They give you a bunch to sample. So I didn't go through and see which ones I thought were interesting enough. So as we go, I'll start turning them on. So you can't work ahead because they're marked as hidden for now. Okay, turn on chapter 2. Like in chapter 3, once we get there, nothing's on yet. So I got that far. So just so you don't feel like they're popping up all of a sudden, like they won't be there until we get to that content. I'll try and get them a little bit ahead. If you're the kind of person who likes to work ahead, fantastic. I don't know very many people who do that, so maybe that's just me here. So so to finish out chapter 1 and then get into chapter 2, I think we talked a little bit about programming. It's more problem solving, which is a lot of fun. It's a very creative process. Errors and warnings are all sorts of fun. So let me pop up Visual Studio here. Again, you only need the community version, which is free. You don't need the bells and whistles. They've got some cool bells and whistles, but at this point, doesn't really matter here. So I'm going to make a new project here. And I'm just going to do an empty project. Again, you've got some other ones here which are fun, but you don't need all the other things necessarily that it gives you. So I'm just going to do the empty project. You can filter by language in case you install multiple stuff, right? So I just want the C++ empty project to start. And now I get to actually do this GitHub thing, which is awesome. Very excited. So I have a GitHub account that I link everything off of. So this is my GitHub account, and I have public repositories for all the class code examples I'm going to do. Again, I think code should stay off of Canvas because Canvas isn't meant for that. Right? GitHub, they sell this as a service for people to put code out there, and it's a beautiful place you can go and find code. All sorts of cool projects. So I'm going to clone this repository. So I'm going to open with the GitHub desktop client. This is what we didn't get a chance to practice in lab. All a repository is a folder. So repositories are folders. Folders can be repositories, right? But not all of your folders are repositories. So if the Git source control tool is watching this folder, it's a repository. Because Git's like, oh, hey, I'm going to track what happens in here. So I'm going to say, hey, I want to take this repository that's online, this cloud-based repository here, and I want to make a copy of it on my computer. So Git is a distributed source control system. Doesn't mean a whole lot, but everyone has a copy of everything. There are other tools that you don't get everything for lots of reasons. For our purposes, we could care less. If you're trying to build the Microsoft Windows operating system, you may or may not want everything. So there's reasons, right? As your projects get bigger and bigger and bigger. So for our purposes, it's super easy. This is going to be small. So you can put it in a different location if you want. This is just a default. So it will default to your documents folder in a folder called GitHub. If your computer has OneDrive installed, often it likes to put it in the OneDrive documents folder, which is kind of funny because then Microsoft has two copies of it because Microsoft owns GitHub. So it'll be in the GitHub cloud and it'll be in the OneDrive cloud. Sure. So you don't need to put it there, but anywhere is fine. Just know where it is. We're going to come back to it. And if you forget, it's easy to find again. So I'll say clone, and now I've got a copy of it on my computer, which is not very interesting. There's not much in here. There's a git ignore file, there's a license file, and there's a readme file. So when I make repositories for you folks, or the GitHub Classroom tool makes repositories for you folks, there'll be a git ignore file. This one's really important because the idea with Git as a source control tool is that it wants the source code. It just wants the human readable code. It doesn't want anything that you can generate, which is when I go and run my project, it actually goes and compiles and does all this fancy stuff to give me that executable we can click on. You don't need to put executables in GitHub. And that's not what it's for. And you can build the executable if you have the code. So we're going to save space on GitHub, and we're not going to bother putting the executables out there because it's made for code. So git ignore says, hey, anything that looks like one of these things, don't put in here. And it's just a bunch of wildcards. So don't put in any exes, any outs, any apps, and all sorts of other stuff. Sure. So that's a default that'll come. Generally, you leave it alone. There's pretty good templates that GitHub gives you. Some people like to customize them, sure. I'm not fond of doing more things that I don't need to do. And then the README file is what shows up in this README here. It's an MD or Markdown format file. If you like that, great. If you don't like it, that's okay too. It's kind of fun because you can take screenshots and like post it in. So I like the Windows snipping tool. I don't know how to do it on Mac, but Windows Shift S. Eventually, you'll just remember it. It's okay. You can like take a screenshot here, and when you're editing your Markdown file, you can go and paste images in, but just by Control-V, paste, or right-click, paste. And you can say, hey, I want to commit my change. Sure, we'll call this update the README, whatever. And now the README file should have the image in it when it reloads. It should. There it goes. It just takes a second. So now I can put images in. So one of the things we're going to do with our projects is I'll ask you to show me that it does these things. So you can just take a screenshot and drop it in your README file. Super easy. Okay, here's item number 1 on the rubric. Here's where a picture of it working in my code. Right? I can run them, so I don't really need the pictures necessarily, but it's good habit and practice for you folks to go through and kind of check it yourself. Like, did it actually do this thing? So if you can get a screenshot of it, you should probably feel pretty good that it did the thing, right? Does that make a little bit of sense? So it's a small pain because, but you're probably doing this anyway as you're testing your program to make sure it does all the things it's supposed to do. When you write code to turn in for a project, I really, really hope you run it. I get confused when people give me code that doesn't run. And they're like, well, that's all I got. It doesn't, I can't hit the run button and try it. And they're like, well, I got confused. Did you ask me? Did you go and meet one of the tutors? Did you get some help? Did you ask your neighbor? Like in the error message, they're like, oh no, I didn't. And I get really sad. So let's try not to do that, okay? Now, if it runs but doesn't do all the things correctly, that's okay, that's fixable, right? But if it doesn't run at all, we've got issues. So, and that's the rabbit trail of, they started with errors and warnings. Lots of things will make your program not run, and it's really annoying and frustrating sometimes. So my project now, I'm gonna put all of the code I do in class in my repository for you. And then I will do this process that synchronizes it with the GitHub cloud, which puts it on the website that all you folks can access. Actually, the whole internet can, because I'm too lazy to try and add you all individually and keep it private. And it's just easier if it's public. I don't care if it's public. Right? I'm not doing anything special. It's just intro to coding examples. So I'm going to change this location here. I don't want it here, so I'm going to hit the little ellipsis, the 3 dots here, and go browse. Go find my documents GitHub folder. Go find, where is it here? Yep, it was right at the top. Cool, so I'm going to put it in this folder here. Now what do I want to call this? So this is the, I don't know, chapter, we'll call it chapter 2. That's, 1 is not super interesting, and then, I don't know, I don't want to call it 1 and 2. So 2, you can check this box to place your solution and projects in the same directory. We're only doing 1 project per solution, so it's fine. Generally, if you have more than 1 project per solution, it gets a little messy, and you don't want to check the box. It just saves you a folder. It's not, doesn't really matter. So I'm going to not check that box because that's my habit. We'll say create. We'll go and make the project. Now, what the Git source control tool does is it watches that folder for changes. It says, hey, my job is to watch this folder. Let me see if anything's different. So if I come back to my GitHub desktop tool, it says, hey, there's a bunch of stuff here. Cool, bunch of stuff. So why did that VS not get ignored? Okay, usually this VS file gets ignored. I might have to go change my file. That's weird. But you'll see this SLN file is a solution file. This VCXproj file is a project file. So solutions are made up of projects, 1 or more projects, and then the projects have additional files. This is not filtering right. I'm unhappy, but it's okay. So there's green because these are new files. So Git is saying, hey, there's something new here. So there's no code yet because we didn't add any code, right? You come to your Solution Explorer, you go to your source files, right-click that and say add a new item, or Control-Shift-A if you like shortcuts. I've never bothered to memorize that one, but that's okay. And let's call this one, I don't know, chapter 2. It really doesn't matter what you call these files. C++ does not care. You get to name them here. There's a couple rules, like you can't have special characters and some things, but it'll tell you if it doesn't like it, pretty much. All right, then we have to type a bunch of stuff, right? Or you could go copy paste it. Again, it's not too bad. So we're going to include IO stream to say, yes, I want to do input and output stuff. We're going to say using the namespace standard, or STD, which is short for standard. And then we say int main, a set of parentheses, and a set of curly braces. Now, Visual Studio is really helpful here. When I type the first curly brace, it gives me the next one. Right? So like I'm not actually typing both of them because everything happens in pairs when you deal with these braces. So it says, I know you started one, so you're going to have to end it. So sometimes stuff will pop up on the screen. That's great. And then again, the white space is just for us. Right? It's perfectly fine if it all touches here. I just like some space. I like the visual separation of things here. It makes me happy. Different organizations have different standards and conventions around how they organize things and the spaces they put in. And believe it or not, some people will fight over whether or not I should hit the tab key or if I should hit spacebar 4 times. 1, 2, 3, 4. Like, literally, people will fight online over this. People need to have better things to do with their lives, but sure. If you like spaces, have spaces. If you like tabs, have tabs. The computer doesn't care, right? I don't really care. Now, the one argument I've heard is that tabs are easier for people with reading disabilities to customize on their screen reader and change the spacing of things. So I would argue tabs are superior just on that basis, that people have said it's easier for them. And if it doesn't matter to us, if we don't have reading disabilities, then we should do the thing that's nice for other people. But again, not, it's not worth fighting over. So I'll do tab because it's 1 keystroke instead of hitting space 4 times. Tab's easier for me, and I'm lazy. Right? We use this cout, or cout. We want to send something to the output here, and then the set of arrows. Right? And then in a set of quotes here, right? If I put in 1 quote, it ends the quote for me because everything is kind of balanced. You start a quote, you have to end the quote. Right? I'm going to say Happy Wednesday. And then another set of arrows in that endl or end line character so that it goes down a line. And maybe I'll do another one here, like it's nice to have internet again. Another end line. And I'm just going to run it, right? Or F5 or debug, run. Any way you want to get to it, great. I'm going to hit the play button to run. And it's going to go do this build process and do a bunch of stuff. And eventually we should get some output. Yep, when we see Happy Wednesday, it's nice to have internet again. Click here to close, press any key. Right? I don't have to add any other stuff to make it not end when I'm done. So we'll press a key and it's gone. We finished our program. Hooray. Now if I come back to the GitHub tool, it says, hey, there's a bunch of new stuff out here. Wow, this is really screwed up. Did I do the wrong one? All right. We don't want all this junk here. This is no fun. Yeah, anything in debug? That seems wrong. I can fix that later, but this should just... Why? I did the wrong one. Well, let me go. It won't be an issue for you, but it's irritating me right now. So I want a GitHub or git ignore Visual Studio. There we go. This is the one I want. Visual Studio. So they've got a set of basic ones, and I picked the wrong one when I made this repository because I'm dumb and I don't memorize a lot of things. So we figured out it went wrong. So I want the one specifically for Visual Studio, not the one that I did for C++. So notice this one has a lot more junk in it because we ignore a lot more junk. Holy cow. Great. So I'm going to grab all that, and then I can go and edit this. So I'm going to go, if you don't know where your files are, you don't remember it was in your Documents GitHub folder, you can go to this repository dropdown and say Show in Explorer. That's your shortcut, and it will pop open that folder for you. It's my favorite shortcut. So I'm going to go edit this git ignore file, open with Visual Studio Code. VS Code's a great text editor. It's got all sorts of other cool bells and whistles. You can do fun stuff with it here. I'm just going to go drop this in on here. It's probably fine that way. It's not going to care if there's a bunch of duplicate things, but this ought to take care of all that for us. Yeah, so anything that's in a debug folder, build logs, those results, yeah, bins, objects, okay. This is a much better ignore here. There we go, so I can close that. Now, now a bunch of stuff disappeared because it's ignoring those files. It is, if you can hit build and it makes it for you, you don't need it. If some of those other files are like user preferences that you don't need to commit because they're going to be different for every user, we don't need to commit them. It's no big deal. So now we see just the important stuff. The solution file, my CPP file, my project file, and specific project filters. Just ignore that. If it changes, it changes. If it doesn't change, it doesn't change. It doesn't matter. But if I see my CPP file, I'm pretty happy because I see my code file. Now what Git makes you do is you have to give this a summary or a message. So Git works on this idea of commits. Commit's a fancy term for snapshot. So the folder, I took a snapshot of that folder of the file contents at this point in time when I hit the commit button. That's all Git does. So it watches for files to change and it makes a snapshot of it, a commit of it. And it will save the state there and it will remember it because it's a really cool tool. So here we'll say, I don't know, Happy Wednesday. And we'll say commit to main. There's all sorts of other things that are not main eventually, but for now we're going to do everything in main. It's a bad habit, but it's more work that we don't really care about right now. So just smile and nod. Now I've got an option to pull origin. So because I made the change to the README file, my copy of the repository doesn't have that change because I did that on github.com. Because that's where you can paste your screenshots really easy. So I have to pull the changes from the cloud down to my computer. So Git is a push and pull system. If you make a change, you can push it out there. If there's a change out of the cloud, you can pull it down. It also works if you're collaborating on a team. If a teammate makes a change, they can push it out to the cloud, and then you can pull that change down from the cloud. So everyone syncs with the central repository, the cloud repository, and then is able to pull their stuff down. Now, depending on where you work, you can actually buy this service to host it yourself if you don't trust the cloud or if you work in government, because they don't trust the cloud for probably good reasons, I suppose. So not always like the GitHub cloud. It could be anyone's cloud because you can have private clouds, and that's a whole other fun story. So anyway, I'm going to hit pull, and it's going to think about it for a second, and it will make the changes to the README file on my computer. So now I'm in sync with what is in github.com. I've pulled down the changes. My copy of the repository is in sync with what github.com has, but now I have to push my changes. I've got changes that the cloud doesn't know about. Sure, so I'm going to hit push. I'll go through and think about it for a minute. Now we're in sync. There's no pushing, no pulling that has to happen, so we have the exact same versions on both sides. Great. And if you want to check here, you can say view on GitHub. If you don't remember the URL for your repository, for my repository, just hit view on GitHub. And now I'll see the chapter 2 folder. I can click the folder, and it opens up like a folder. It says, hey, here's what's inside of it. The solution file and another chapter 2 folder. This is the project folder. So you got to click a little extra if you have project folders. That's okay. And here's the CPP file. I can click on that, and now it actually shows me the contents of the file. So I can see someone else's code without having to make a copy of it and open it up in Visual Studio. I can just look at it online here, which is cool. The other really nice thing is the line numbers here are clickable. So I can say, hey, line number 7. And now the URL ends with the # line 7. So if I take this URL and send it to someone, or if you're having problems with your code, you can commit it to GitHub, grab the URL and send it to me and say, hey, Eric, I'm having trouble at this line. Here's the error message I'm getting. I can actually see what's happening right in your code there. At this level, probably 95% of the time, I don't even have to open Visual Studio. I can just look at your code on GitHub and I know what's wrong. 95% of the time, not always. So that saves us a lot of time. You don't need to email me files. Please don't email me files. It's actually really annoying to take CPP files and try and add them in and load them up and that sort of thing. Just we're going to use GitHub because GitHub is made for code. It'll make all of our lives easier, I promise. It'll be a lot of clicks at first, but then you'll get used to it and you'll love it. And you'll use GitHub for the rest of your lives if you stay in software. So, or until a better tool comes along. So anyway, you can just grab that URL and send it around, and people can get the shortcut right to that line number. Now, with 7 lines of code, it's not very interesting. But as your projects get bigger and bigger and bigger and bigger, you might have hundreds or thousands. I don't think we get to thousands. Hundreds of lines of code. It's probably as big as we get here, right? It's nice to have the link to the line number. All right. So now as I'm doing more with this, right, we can do other things like cout. Now, C++ knows how to do math. Go figure. You can make the computer do math. So we can do something like 7 times 7, and then an end line. Now, notice this is not in quotes, because if you put something in quotes, you want that text to show up. I don't want the text 7 times 7 to show up. I want the result of 7 times 7 to show up, right? So I can do it twice and show you. So cout, you can say 7 times 7 here. And it uses the star key, not the X, which I think makes sense. Some people get confused if you're used to using X in math classes. Eventually we started using the dot, right? When you get far enough along and you're all taking calculus because you're in this class, right? It's a CoRec, I think. Isn't Calc 1 a CoRec? Which sucks if you didn't, I'm sorry? Prereq? That's it. Oh, geez. How do you do that if you haven't had, okay, whatever. That's a weird issue. All right, so we'll do 7 times 7 in quotes and 7 times 7 here. And as you'd expect, we'll get the result of 7 times 7 is 49. You guys all guessed it correctly. That was not a hard one, right? Let me zoom that in a little bit. Okay, so if it's in quotes, you get that text literally. If it's not, it's going to evaluate that expression and do the arithmetic, right? How about, what's another math problem we can do? We're going to see if we can do math, right? What about like a division? Okay, what should we divide? Like 7 divided by 5. Okay, let's try that. And then I'm just going to do it again in quotes, just copy paste and throw some quotes in. Now, okay, so we were started here looking at errors, and I got off track here, talking about errors and warnings. If I don't end the quote, notice I get a big ugly red line here on the screen. And if you hover over it, it says missing closing quote. If I try and hit run here, it's not going to work. It says build failed. There were build errors. Would you like to continue to run the last successful build? Never click yes to this. This is the most obnoxious dialog box. I don't know why. If it doesn't work, it says, do you want to run what used to work last time? No, because I made changes. I want to run the new thing. So if you hit yes here, you get the old version, and then you're going to be confused. So never hit yes. Right? And you can even tell it, please don't show me this anymore. Right? Just tell me no. I don't check that because I want it to pop up so people see that it's supposed to pop up or will pop up for them too. And if I hit that, it goes away, and then people are like, I've never seen this box before. Where do I click? And I get 30 questions. So I'm just going to say no. Now there's a new window that popped up, or a new section of the window that popped up. This is the error list. So with the error list, it tells you all the things it doesn't like about your code and why it won't run. Now there's 2 errors here, but just 1 red line. The first one says missing a closing quote. The next one says expected a semicolon. Now the funny thing is, when the computer goes to read our code, it says, hey, you opened a quote. Until I find an ending quote, I assume everything is part of that quote. So that's why it says it's missing a semicolon, because it thinks that that is part of the quote here that I want to print out, right? And deal with as a bunch of characters. So I can't just add more semicolons. Like, it's not going to be happy with just adding more semicolons. It doesn't fix the problem. So sometimes it gives you more errors than you really need. Right? Or the first error causes the next error. So it can be a little obnoxious sometimes to figure out which is the right one to fix. Well, once I put my quote in, I'm good. If I actually miss the semicolon, now this is helpful. It's expecting a semicolon. Right? In C++, we love our semicolons. That tells the computer that that line is done. I think I mentioned you don't actually need all the new lines. You don't need all the white space in here. So I can take all of this and I can condense it down to a single line here, which is a terrible, this is like a crime against humanity to do this, but you can. This is awful and I feel really bad. There. Oh, let's even do these ones here too. There. I can hit run. Oh, build errors. Uh-oh. Okay, what do we do here? Oh, these, okay, sorry. That one I can't. That one doesn't have a semicolon. My bad. This ought to run. Yay! So 7 divided by 5 is 1. Huh. That's fun. We'll talk about that in just a little bit. But that's what it gave us, right? But you can see on a single line, it works just fine. But it's terrible. We don't like it. So I'm going to go to Edit and Advanced, and I'm going to say Format Document. This is my favorite shortcut in the world because it will reformat this in a sane format here. All right, it did not. It should. Let me try that again. Edit and Format Document. Oh, come on, really? All right, it's not working right now. I'm very sad. I can go back and fix this myself. Look, I did it to myself. Okay. Throw a couple of these here. Okay. Now I made it look pretty again. It makes me happy. There's a rule of thumb, and it's a convention that people follow, is that when you're reading someone's code, you should not have to scroll left and right. It should fit on the screen. Now I'm zoomed in a little bit here, so I might sometimes go past that limit. At one point, the fine folks at github.com would actually limit the size on the screen to 120 characters because they were very adamant that you shouldn't have more than 120 or whatever, 160, some number of characters per line. And they were going to punish you if you did that by making you scroll left and right on the website rather than just expanding the website, because obviously they were right. Software engineers are weird. We're just weird people. But generally, you don't want to have to scroll left and right. You want to be able to see what's happening on the screen because that makes it easier for you to follow. Code here is really meant for humans, right? It has to follow the rules that a computer can read, but we write code in the way that humans can read it, right? You want to be able to read it. I want to be able to read it so I can evaluate you. When you go out and work somewhere, your team needs to be able to read it. And you folks will move on to bigger and better things, and then it'll be someone else's job to keep up with your code and maintain your code. So it turns out paying software engineers to write code is very, very, very expensive for businesses. So what they want to do is they want to make money off of it. Go figure, businesses want to make money. So they're going to keep that around as long as possible. They don't often pay someone a week or month worth of time to write some software and then throw away the software a week later. We don't often do that because it doesn't make a lot of business sense. Yeah. So someone wrote a tool to automate their job and then forgot how to do their job. Yeah. Wow, for 30 years. I mean, the first job my brother had was in COBOL, and he hated it. And he would tell me he spent most of his days writing code to automate the things that would take him 10 minutes to fix manually, but it irritated him to have to do that every week. So he'd spend hours and hours and hours figuring out how to make it automatic or take like one push button. Because software engineers are lazy, right? We don't want to do more work than we need to, and if we have the tools and ability to automate things, we like to do that. Sort of, I don't know, I think it's entertaining to be able to say, this used to take 20 minutes as a manual process, and now it's like I can click a button and it's done. Great, that's kind of cool. Now, organizations who pay you to do sorts of things, that gets to be a really interesting gray area when you have a set of tasks that they're like, hey, this should take you 40 hours a week, and you automate it and automate it and automate it and automate it, and it takes you 4 hours a week. Well, ideally, you can then go do more things, right? But if you don't tell anyone, and like your story, this guy automated their entire process away, I don't know, go take the ethics class. Wow, that word should not be that hard. Go take an ethics class, and you can decide for yourself if that's right or wrong. So I've got opinions, but I'm not always right. Go figure. Okay, so 7 divided by 5. Remember, it came out as 1. So, is that a question? Yes, so you probably got ahead in the chapter 2. So when we deal with numbers, C++ treats numbers differently. So there are integers, which are whole numbers. And we're all familiar with integers thanks to math class. And then there are floating point numbers, numbers with decimal places is what I like to call them, because float makes no sense to me, floating point numbers. Like, sure. So somewhere in there's a decimal, and there's some X number of decimal places and whatever here. So if we're dealing with integers, and you do arithmetic with integers, you will get an integer result. So 7 divided by 5 is 1 point something, but because it's an integer, you lose the point something. So C++ says you only want the integer. You ask for an integer. Great. Well, turns out if you want numbers with decimal places, you use numbers with decimal places. So 7.0 and 5.0, 0.0 and 0.0, we should get a better result here. Excuse me. 1.4. So if you give it a number with a decimal place, it knows it's a floating point number. Our technical one for this is a double, and that's lots of reasons we can talk about later. It will do that sort of arithmetic, dealing with decimal places. Now, the computer has to do different things to deal with integers when it deals with floating point numbers. Turns out integers are faster because you don't have to deal with all the decimal places. So if an integer works, integers are great because they're faster. Doubles are great too, but they're a little slower because it has to do more work behind the scenes. So sure, right? If it fits an integer, great. If you're not sure if it's going to be an integer value or not, go with a double. It's not too bad here. Okay, so we can output some things. So this again is not the most interesting program right now because every time I hit run, it's going to do the exact same thing. And sometimes that's okay. Sometimes that's what we need our program to do, is the exact same thing over and over and over again. Other times, we want it to do different things based on something the user enters. Eventually, we'll get to working with files, and then we can read files and do sorts of fun things. We're just not there yet. So if I want my program to do something interesting, like get some input from the user and do something with it, we can get input. So let's say we were going to calculate how much money you're going to make. That's a pretty simple example here. So we could say, so let's take some numbers here. So we'll have cout, if you make, how many dollars an hour do you folks want to make? We're making it up here. So go shoot for the moon. $32.50. When you shoot for the moon, you only make $32.50. Okay, all right. A realistic moonshot. You know, fresh out of school, right? So that's like $65K a year or so, right? It's like doubled and then times 10 or so. Okay, sure. Yeah, why not? So if you make $32.50 an hour, you would make, and then let's have it do the arithmetic here. Now, if I don't add the end line, or I don't add a semicolon, I can just keep on typing, right? So if you don't like having to put a bunch of endals in here, or you don't like having to go down a bunch of lines, because I don't want to go off the screen here, I just keep on typing, right? Because what C++ does is says, hey, you started some code, eventually you'll hit a semicolon. That must be the end of your line. So if you don't end the semicolon on this line, it just keeps on reading. Sure. So we'll say you would make, and we'll do the arithmetic. So it's 32.5 times 40 per week. And we should preface this with before taxes. Right? That's important because taxes will change the amount of money you take home. So, right, so we can just do the arithmetic. And let's see what we get. 1,300 per week? Oh, we forgot our dollar sign, right? We like dollar signs, so that we should put a dollar sign here, right? Because it's just going to smush everything together. So if you don't put in your spaces here, right, you won't get spaces. This is one of the things about Xylabs. If you don't have the right spaces in there, it's going to yell at you. So you'll have to go in and add your spaces. It might also be fun then, right? We can calculate. So I'll put this on the next line. So I'll add my end line here and keep on going, but I don't need to end it here. I can just keep it saying. So we added an end line, but we're going to keep on printing more things. And then that works out to so that's 32.5 times 40 times 52 per year, right? I think that arithmetic checks out. 52 weeks in a year? Sure. Oh, I forgot my end line. One more end line. I went a little bit off the screen here. I'm sorry. The Solution Explorer is not all that interesting to have open. But if we don't like it, you just enter down. Just go down some more lines. Doesn't really matter. Now, the part of me that likes things to line up right wants the arrows on this side instead of that side, because now I like arrow, 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 arrow. But again, it doesn't matter. It makes me happy. The computer could care less, right? Let's run that. So let's see what that works out to be per year. Right, 67, okay, yeah, pretty close. Pretty close. Not too bad per year. You zoom that in. Is that better? All right. So, but every time we run this, it's not very interesting because I'm going to get the exact same result, right? And not everyone is going to make 32.50 an hour, right? So we should make it be flexible based on what the user wants to give us. So if we want to ask for input, we can do that. Now, the problem is when you ask for input, you need a place to store that input. The computer needs to know, where am I going to hang on to this later? I can't just ask the user to enter something and it magically shows up. So now we get to our favorite topic, variables. We get to say, hey, I want a variable in my program, something that the value of it will vary. The value can change. It's variable. That's why we call them variables. It's a fun story. So I need to tell C++, hey, I want a double here because I want it to store a number with a decimal place, right? Because you probably make some number of pennies per hour. And if I truncate that and just take the integer result, you will be very unhappy with me, right? And we'll probably be committing employment fraud, right? Which weirdly is not actually a very penalized crime. So for an employer to steal money from employees by not paying with wage theft, it's not, they don't get punished very much. Like they give you the money back, there's like a small fine. But if you steal money from an employer, you're on the hook for a lot, right? And you could be charged with a felony depending on how much money it is. So just a fun fact about laws there. So anyway, I'm telling C++, hey, I need to store a double here, and I want to call it something. Now, C++ doesn't care what we name our variables, aside from a couple rules around you can't start with special characters. I don't think you can start with numbers. You can't have spaces, and a couple syntax rules. But aside from that, the name of your variable is up to us. It's up to people. They're programmer-assigned names. Now, we want our names to be meaningful. So, like dollars per hour is a terrible name. This is awful because a minute later, I'm going to forget what DPH means, right? I have no idea. And it's just as easy to say dollars per hour if you like the underscore. Some people favor the underscore character to separate these things. This is snake casing. It's not as common in C++, but it's very common in Python. And I do a lot of Python, so forgive me if I do snake casing. Right? Generally with C++, we do camel casing, and we capitalize the first word of each next word, first letter of each next word. So it's relatively easy to see this is dollars per hour here because you have capitalized the letters. The whole idea is you should be able to see it and read it. So if you don't have that, if it's all lowercase, that's just a mess, right? Like, it's amazing. 2 capital letters makes it so much easier to see what this word is. So dollars per hour with capitalization here is really nice, right? And generally with variables, they start with lowercase letters. We'll get to sometimes we'll use capital letters for things, and it's just a convention. C++ doesn't care, right? And now I'm getting a little dot here, but I'm not getting an error. It's not a red line error. It's just a warning. And if I hover over it, it says local variable is not initialized. Initialized is a very fancy technical term for you never gave it a value, stupid. You told me you wanted something and you never used it. So C++ is telling me I did a dumb thing. Well, C++, thanks, but I'm just not there yet. I'm a little slow. I'm not dumb. I'm just slow. Right? We'll get there. So, okay, sure. So now I said, okay, I want a dollars per hour. Now, if you want the user to enter something, you have to tell them what they're supposed to enter. So I'm going to say cout, enter your, I don't know, wage, hourly wage, right? Sure. And then some people like that to not have an end line, and they just end it here, because that way you'll type right after the colon. That's just a style preference. Some people will add an end line. Again, it doesn't really matter. It's whatever style you like here. I'm just used to putting end lines everywhere, so I will always have end lines, because it's just what I have. So if you don't like them, that's fine. If you do like them, great. Doesn't matter. Now that I've outputted something, now I can get some input. So on Monday, we looked at this CIN idea to get them input so that my program wouldn't close, but Visual Studio does that for us already. But I can say CIN dollars per hour. So the user will type something and hit the enter key. Whatever they've entered now, I'm going to try and input as dollars per hour. Cool, so now I have a variable here, dollars per hour, that probably has the number the user typed in. So I can use that in my arithmetic. So I don't need to hard code in here 3250, right? So I'm going to just end that quote here, and then I'm going to add in the dollars per hour. Now, notice there's another red line here. It says it expected a semicolon. But we're not actually missing a semicolon. What we're missing is the double arrow, the output arrow. So sometimes the error message is not exactly what you want. So technically, I could have just ended that with a semicolon. So that's correct here. But then once I added that, now I get another line. Expression must have an integral or unscoped enum type. And you're like, what does that even mean? It's not a very helpful error, but you can't start your code with a string, is all. You can't just put some text on a line. It's like if I had said here, enter a number. It's going to be really confused, like, why do I have this here? Because this is not meaningful, right? So it just gets confused, that's all. So sometimes your errors are tricky. That's okay, right? Once we've seen them a couple times, they'll start to make a little bit more sense. So, all right. So dollars per hour, and again, I'm going to use that number here. So I can use my variable name, the name I gave it, in place of a value. And when I do this, C++ says, hey, go get that value I'm hanging on to somewhere. So when you create variables, it stores them in memory. So if we go back down to computer hardware basics, right, we've got memory is your RAM, that's the fast stuff. But if you lose power, it goes away. Right? It's volatile storage, but it's really fast and quick. Storage is like your disk storage, your flash drives. Do people use CDs anymore? Like physical storage, where if you lose power, it's still there because it's stored. It's not just held on in memory. So when we use variables, they're in memory. So they only exist while the program runs. So sure. So dollars per hour, and then again, dollars per hour, dollars per hour, dollars per hour. So I think I replaced it in all the places. So let's give it a try. It might work for us. So enter your hourly wage. Well, let's do 3250 again, because we know what the answer was supposed to be. 1,300 per week, 676K per year, or 67K per year. So that math checked out. Again, it's really important to know what should come out. Because if you don't know what's supposed to come out, how do you know if you did it right? Because it's really easy to typo things, right? If I just like had an extra number here because I wasn't paying attention, or if I screwed something up, right? I'm going to get good calculations, but it's not correct because it does what I told it to do. It has no idea that it should be 40 here, right? So you want to be able to make sure you know what's supposed to happen when you run your code. You can check and make sure it did the right thing. Okay, so let's try it again with a different value. Now, the whole point now is that I can have different kinds of input. I can have variable input when I run my program, and now it's a little bit more interesting. So what's another hourly wage? $80 an hour, all right. 3,200 a week is 166K and some change per year. Cool, I think that worked. Right, if you want, we could check the math ourselves, right? Open up the calculator here. I always check it like once or twice, because it's not that I don't trust C++, it's that I don't trust myself doing the math right? So I'll just double check. So 80 times 40 times 52, yep, looks good. So I think we got all the numbers right. So now our program's really fun. So that's how much we make before taxes as a variable. So if you want to use variables, we have to tell C++. The technical term here is declaring a variable. We've told C++, hey, I want a place to store a value. And by the way, it's going to be a double, a number with decimal places. Now, other fun errors you get here are when the users do things you don't expect, like enter your hourly wage. I say 10. I got 0 now. When I tried to input dollars per hour as a double, the letters T-E-N are not numbers. C++ kind of choked on it. It was like, I don't know what to do. I'm going to give you 0. Good news. So, that's not great. We'll get to how to deal with validating input later. It's kind of beyond us at this moment. So, sure. we'll just assume the user does the right thing, which is very risky. Right? Users will do all sorts of crazy things with our programs. It's kind of hard to predict the weird things they come up with. But that's okay. So for now, we're going to assume they do the right thing. Later, we'll learn how to assume our users are stupid or even malicious. That's a whole other category of user. Some people have so much free time on their hands, they enjoy trying to break things. And they will maliciously try and break things in your program. And then some of them will go use that to exploit things and go put malware on other people's computers and exploit them for money. Right? I don't know what happened recently over the weekend at U of M, but I imagine something like that probably happened, given they had the FBI involved. So, or federal law enforcement. I think is FBI, right? Probably is. Weird stuff will happen. So not only do we want to make sure that it works correctly for dumb people, users who do dumb things, we want to make sure it doesn't break when people try to do bad things on purpose, right? So all sorts of fun things there. You'll get into eventually looking at how to secure your code and do those sorts of good things here. There's this, which is amazing here, this OWASP top 10. So the top 10 security vulnerabilities. That doesn't look like the right site. Yeah, there we go, OWASP.org. There we go. So we know that there's risks and vulnerabilities and things that can happen in our code. And people publish these articles and tell people all about it here and say you should protect against these things, and it still doesn't happen. Right? It's hard sometimes to do all of the right things all the time and to be perfect. It's really hard to be perfect. But you want to try and protect the best you can against them there. Here's an interesting one here. This is new. Okay. This injection attack. We've known about this style here. So this means when you ask for input, you do something funky with the input, and you either try and give it bad input or overflow the input or do all sorts of funny things here. We've known this has been a problem since like probably the 60s, at least the 70s, and yet it still happens all the time. But that's okay. So there are still hard problems and things that we want to fix here. But sure. All right, we're getting off track here. I'm sorry. All right, errors and warnings, computer programs, tours, language history. C++ is really cool. It's been around for a long time, does a lot of really cool stuff. They keep adding new features to it, which is great. You can go read that later. White space again for people, some example. Oh, the salary. Okay, they already did a salary calculator, sure. That's about it for chapter 1. Feeling okay so far? It's a lot, it's okay. So let me take a minute here, and I'm going to come back to my GitHub desktop client. And it's going to say, hey, this file is changed. I get an orange dot here. It's not new. I didn't delete it, but it's changed. And what Git is really good at is tracking changes at the line level, which is going to be really important as your programs get bigger and bigger and bigger and bigger. So it says, hey, your lines 3, 4, 5, and 6 are gone. They don't match anymore. You have new, so on the left is the old line numbers, on the right is the new line numbers. Green means it's new. Red means it's gone. So we can see there's a bunch of new stuff here. Sure. And it's like, oh, hey, your last two lines, 9 and 10, are now down here. Sure. So it tries to piece these together of where stuff matches and track the changes at the line level. So we'll say, here's the salary example. So I'll make a commit. It takes a snapshot of that point in time, and then I'll push to go synchronize with the cloud. Once you've pushed, right, it has it. It's really hard to lose your code once you got it out to the cloud. GitHub makes their money and stays open as a business because they charge people for this service. And you don't make a lot of money if you lose people's code. Is that right? Fair to say? You're not going to get a lot of customers if you lose stuff. So once it's out there, it's really hard to lose it. So I would encourage you as you're working to commit early and often. Just a fun phrase. Commit early and often, because the more often you commit and the earlier you do it, the less you're going to lose if something bad happens. Right? I have a toddler who loves to get into things, and one day he got into my office, took my cup of coffee, and poured it all over my laptop. It was real sad. It died. But I had to commit. So I lost maybe half an hour worth of work because I stepped out to go get something. Right? If you don't commit to the end of the day, right, the longer that delta is, the more you're risking if a bad thing happens. That's all. So lots of commits are great. They're free. They're no charge to you. I mean, it uses electricity and bandwidth and resources and things, and I'm sure there's some sort of cost somewhere. But you don't have to pay it. So who cares, right? I feel a little bad saying that, but it's not that much electricity. Like, it's not like Bitcoin, so it's okay. All right, so I can go view on GitHub and make sure it got out there if I want, right? If you're the kind of person who likes to double check and make sure it's great, go for it. This is your sanity check, right? Did it actually go out and make it out to the website? I'll go check. So the rule of thumb is if you can see it on github.com, I can see it on github.com. If you can't see it on github.com, I can't see it on github.com, right? If I can't see it, I can't score it, right? And if I can't see it by the deadline, you don't get points for it, right? Because the deadline is the deadline for our projects, right? We don't take them late. So just go look on the website, which you're going to go anyway to grab the URL to submit to me in Canvas. So you're going to have to go out here anyway. So just give it a quick look. Make sure it has your latest version, right? Sometimes people will commit and then forget the push button. I wish it like did both at once, but sometimes you don't always want to. That's a whole other story. So if you forgot to hit push when you go to the website, you're like, hey, I'm missing half my code. Well, you can come back here and see, is it waiting for something? And thankfully, all those buttons light up in blue. Like when there's something to do, it lights up in blue. And it's like, hey, click this button, which is nice. Okay, so we got our latest version. We can grab the URL, we'll be able to turn it in. Life is good. Now, this is my public repository for the class. For all of your projects and labs and things, there's a classroom GitHub tool, which is really cool. You can get all sorts of fun features. I don't use most of them. That will make you a private repository. A private repository means just that. It's private. It's not public to the internet. So you'll have access and I'll have access, which are the only people who should have access, right? So no one else will be able to see your code online except for me. So you can give me the URL and it won't work for anyone else, which is good, right? Because you don't want someone to copy off you unintentionally, right? That'd be bad. So private repositories are great. I'll get you set up for that when we do our first project next week. And then for the first lab, which is, I'm sorry we missed Monday, it'll be okay. It's a couple steps, but it's not too bad. Yeah. Next week, we're going to finish chapter 2, right? Let me double check. I think that was the plan. So we've got more intro today. Yeah, we're finishing the intro today, starting chapter 2 today. Next week, right, we don't have Monday for Labor Day, and then we'll finish out chapter 2, and we'll talk about the first project, Project 0. Then we'll have our first lab on 9/11. So, yeah. No, just on Mondays. Yeah, and there's no time to like reschedule because I don't know what all your schedules look like, and it won't be bad. Right? Your first lab is essentially this: like make a hello world and commit it. I ask you to put a couple more things in. That's all. So no class Monday. Don't come here; you'll be lonely. So there might actually be activities, but don't come to the classroom. No one will be in the classroom next Monday. I don't know, are they planning to do stuff? Sometimes they do events for Labor Day. I'm so behind, and I don't know if anyone has like thought that far ahead with everything that's been going on this week. Oh, there is an event though. Goodness. Airborne Engineering Blue Day? Is that right? Blue Carpet Day? Blue. I come up with the funniest names for things. Here we go. Blue Carpet Day. Yeah, okay. This is tomorrow from 11 to 1. Anyone who is a new student in the College of Engineering and Computer Science or a freshman is invited to come out and learn about the College of Engineering and Computer Science. And there's food. Yeah. Lunch will be provided. I'm pretty sure you have to register if you want that lunch. So I'll post this in Canvas. Yeah. So the commit to GitHub will be the exact same process. Yep. So on Mac, you can use the GitHub desktop client for Mac, and all the same things will work. Yeah. It's hard to switch between the two just because they use different projects. The code itself will be the same, but you have to like load it up in an Xcode project or load it up in a Visual Studio project. Whichever one you like. Switching will be, it's not the end of the world. Like you can just come in here and copy paste if you want, or yeah. We'll have computers here on campus that have Windows and things. So I like Windows better than Mac, but that's just my personal failing. So whatever you're comfortable with. There's like online compilers you can use too. They don't do as many cool things with Visual Studio, but that might be an option. Doing C++ in Visual Studio for Mac is rough, last I heard. Yeah, it's so VS for Mac, Studio. Yeah, I don't think it does what you want it to do. It's not designed for that. So, yeah, lots of workarounds, but it's rough. And so, yeah, would not recommend it. Sorry. Um, what do they want it to like? They usually it's like the C# stuff that they wrote it for, which is another language. Does other sorts of fun things here. So that's all. All right. Oh, so Blue Carpet Day. I'll post this link in Canvas here. Check it out. Should be fun. Get a meet and greet with people and find out who's who in the college. Fun lab visits. Sure. Yeah. Fun. Hands-on activities and student competition teams are really cool. There's a couple cool groups that do competitions. One of them that I think is super interesting, just because I'm weird like that, is autonomous snow plowing. I don't know why this became a thing, but there's a competition every year for which school can build the best autonomous snowplow, which is a really interesting challenge because unlike just self-driving, you got to put the snow somewhere, right? Like when you plow a parking lot, the snow ends up somewhere. So being able to manage that on top of how do you drive into things and not hit stuff, especially in a bunch of snow, is really interesting. So I think that's kind of fun. There's also a club that builds rockets, which if you like rockets, that's cool too. I'm not as partial to things that go boom because I don't trust myself to be good enough at that. They follow all the right safety things and have a faculty member who like knows what they're doing and actually has worked with. I think she used to work at NASA. I don't remember if she's still the coach or not. An actual NASA engineer, like coached the team a while ago. But anyway, so meet the teams. They do some fun stuff. If you like robots, I think there's a robotics team. I forget what they all do. So lots of cool stuff. And lunch, of course, free lunch. Can't beat that. So register. I'll post that link in Canvas. I'll just leave that open so don't forget. All right, how are we doing? We got 15 minutes left. Nice. All right, so looking at what we're doing in chapter 2. Variables, expressions, awesome. Floating point numbers, great. Constants, math. Okay, so a couple other fun things. So we did some basic arithmetic here with multiplication. We did some division here. There's another fun one. So if you remember back to 3rd grade math, when we first learned long division, way back then, right? You'd solve the problem and you'd have a remainder because we didn't learn how to do division with decimals yet. And that gets confusing for kids. You're like, oh, just keep adding zeros. I was trying to teach my daughter. She's like, where do they come from? I'm like, well, they're always there. You just don't see them. She's like, what do you mean they're always there? No one's put zeros at the end of their numbers. I'm like, yeah, we don't have to. Sure. So it gets a little awkward sometimes. But the remainder is sometimes a really useful number to know, depending on what we're doing. Now, to get the remainder of something, we use what we call the modulus operator. So I don't know why. That's just what it's called. So to do that, let's even ask the user. So we'll practice doing that. So I'll say, hey, I want an integer for first number, and I want an integer for second number. And I'll ask the user. So cout, enter your first integer. Sure. And then we can see in the first number. And then we'll do the same thing for second. Now, I'm lazy. I'm going to copy paste this here. Enter your second. Now, I don't actually type all these things. So when I mention using good variable names, like that are long and meaningful, it doesn't mean it takes longer to type here. So I type like SEC, and it pops up and says, hey, do you want this thing called second number or any of this other nonsense? I don't know what the other nonsense even is, right? If I start typing more, second number, I just hit tab, and it finishes the typing for me. It's autocomplete, or IntelliSense, I think is the trademark term for it, or something like that, right? So you don't need to type the whole thing, or you can copy paste. If you double click something, it'll highlight the entire word. Turns out if you smush all your letters together, it's all one word, or as far as a double click is concerned, so that I can Control-C copy, Control-V paste if you want. If you triple click, it gets the entire line if you want to copy an entire line. Again, Control-C copy, Control-V paste, sure. If you like shortcuts. I use a lot of them. I'm sorry, I'll try and explain them as I go. But I'm all about the shortcuts because I don't want to do more work than I need to because I'm very lazy. I'm efficiently lazy, right? I'm a better person because I'm lazy. That's what I tell myself at least. All right, so then we can see, let's do some math with the numbers, right? So we'll say your first number minus second number is, and we'll do first number minus second number. second. There we go. And then line, okay, let me bump that down. Right, it's getting a little long, so we'll bump it down. We'll do some different arithmetic. We can do all the different operations here. So let's do plus, plus. Let's do multiplied by, and let's do divided by. Now, remember, when we do division here, we lose any decimal remainder, which could be bad, right? So what we're going to do, in addition to the regular division, is we're going to take the remainder as well. So instead of this end line here, we'll say remainder, oops, not those ones, sorry, too many double arrows, remainder. And then my remainder operator, what modulus does is it gives me the remainder. So first number modulus, which is the percent sign, which is confusing, but sure, it's a percent sign. Second number. So it'll give me the remainder, right? Because I'm dealing with integers, I know I'm not going to get that double result, right? If I wanted doubles, I could use doubles and we get a precise result, but this is dealing with integers, so we'll get an integer result with an integer remainder, which is great. I mean, it's just as precise, right? And then you get to teach the kids about fractions. You're like, hey, the remainder over the divisor is the fraction result, and then you can figure out what fractions are. Math is kind of fun. I found it fun, at least. People who don't like math don't find it fun, I apologize. You're going to do a lot of math if you're in computer science, which I'll just be honest right now, most of you will never use again. So I think it's kind of dumb we make people do a bunch of math to do computer science, but this is my opinion. And I'm happy to be wrong a lot, and that's okay. But it depends on your field, I guess. So some fields will use a lot of math. Other fields will never use a lot of math. The guy I used to work with got a double major. He's like, hey, I take so much math for computer science, like 3 more classes and I can get a math degree or a math major as a double major. And he did it because it sounded fun. And then he's like, I've never used that math ever again in my life, 20 years later. But sure, like some people will, and it depends on your field. My brother's friend from school got a job at, AutoCAD, who does CAD software, and his entire master's thesis was on how to draw curves and calculate curves more efficiently. Talk about boring, right? But it got him a job at AutoCAD, and he makes a lot of money doing AutoCAD stuff because it turns out drawing curves is really important when you do 3D modeling of things. Who knew? So sure, like there's something for everybody, right? If you're into that sort of thing, go for it. It's great. I'm not, so you're going to hear a lot of my biases. The things I'm not interested in, I'm very passionately not interested in them, because the things I am interested in, I'm very passionate about as well. So I know enough about myself to know that I can't do everything. So I'll focus on the things I'm good at, and that makes me happy. All right, let's give it a try. So again, using some input. So notice I declared them first. You don't have to like declare and then input right away. You can declare them first and then come back to them later. You can declare them at the very top of your program and come back to them later. Some people will argue that if you have variables, you should declare all of them at the very first thing in your code. Sure, like, okay, that's one way to do it. The thought behind that is if you know what your program's supposed to do, you know all of the variables you're going to need, put them at the top. That way they're done. Then go and use them later on. So sure, when I tend to do things though, I know a lot of what I'm going to need, but I don't always know everything I'm going to need. And then to go back and put variables back at the top when I'm making it in the middle of my program irritates me. And it turns out there's tools that will sort code for you and organize code for you. That you can just click a button and it'll do it for you. It's like even better than this format document. So not really worth a whole lot of time, in my opinion. Some folks who teach here are very particular about that sort of thing, and I cannot change their minds. So sorry, I tried. So if any of your profs are particular about where you declare variables, just smile and nod and do it. It's not hard, right? You could be irritated that it takes you an extra 10 seconds to copy paste. But it's 10 seconds, really. It's not the end of the world. All right, so hourly wage, we'll just do like, 1 minus, sure. 1 minus, my first and second integer like automatically showed up as something here, and I get negative, what's that? That's ones, thousands, negative 858 million. When I subtracted, I get a positive, and this is weird stuff. It's bad. So if you enter weird characters, the input gets messed up because it wasn't expecting that. So let me try that again. Input's very particular. But once we learn how to deal with input, you'll be much happier. So let's try 10. Okay, what's our first number now? 6. And what's our second number? What? 4. All right, plus 10 minus 2 multiply 24, division, 1, remainder 2. I think that all checks out. So cool. Now, we're not always going to need the remainder, but occasionally it's useful. And it might be nice to know what the remainder is. And getting a remainder without the modulus operator is actually kind of obnoxious, right? There's ways to do it, like mathematically, you can just like keep subtracting until you get less than the number you're subtracting, and then stop, and your result is that. But like, that's a lot of work for us to do, right? And we don't want to have to do that. So modulus is great. So keep that in your back pocket. Conversions, binaries, characters, strings. All right, we're going to leave some of this for next week. So I think that's actually pretty good for now. We can come back to the rest of it later because we have to have something to talk about next Wednesday. That sound good? All right, questions, thoughts, concerns? We okay? It's been a rough first week. We're getting there. Hopefully the rest of your classes are going okay. I would love if you did the chapter the week we covered it. The amount of time it takes me to run the report and enter grades week by week by week, honestly, I'm not going to do it. So at the end of the semester, I'm going to run the report one time and I'll plug in that score because, yeah, for your sake, it's best to keep up with it because then you're keeping up with the material, just like reading the textbook. So you like get points for reading your textbook essentially, which is cool. Well, we started it today and we're going to end it next week. Yeah. Yeah, so we've got chapter 1 and chapter 2. Start on chapter 2. Don't feel like you got to finish chapter 2 right away. We've got a week to do it. If it's not done on time, I'm not going to notice because I'm not going to bother running the report. I'll just be honest. But if you haven't like read the stuff and practiced it, it's going to be difficult. The idea is you're keeping up and you're not getting behind because once you get behind, it's like math class. The stuff keeps moving and building. Right? If you didn't do the stuff from week 2, the stuff in week 3 won't make any sense because it uses the stuff from week 2. Stuff in week 4 uses the stuff from 1, 2, and 3, right? So it just keeps building and building and building and building and building here, which is lots of fun. So if you're getting behind, let me know. Reach out to me. We've got the Engineering Success Center, I think is what that's called. I saw the name on the room there. They've got tutors available at some point. We're just getting things up and running today. The internet, like at 10:38, they email. I'm like, good news, you have internet again. Thanks. Actually, I was really happy they fixed it, but yeah.
Like you say, you don't want to get picked on it because in each section there's a lot of parts where it really just makes you type out what it wants you to type out, and it'll tell you what's wrong with the space on the period. But like you skip all the way just to the parts that makes you do it. It does take a long time sometimes if you leave it to the last second. So
Yeah, just following along doing the typing exercises is it's a lot of work. I apologize, but the mantra here is you don't get better at coding without coding, and the exercises here are coding. So it's good for you because you want to be good at coding, right? You're taking a coding class. This is awesome. Yeah. So hopefully you'll enjoy it. Generally, people have positive feedback aside from the labs are tedious. I don't have a way to fix that really. So it's just practice. All right. So I'll stop the recording. I'll post that out to YouTube for you later if you want to watch it later. Again, if you're sick, don't come. Please. I have enough germs with my 7 kids at home. So just stay home and you can watch the recording later. The folks who do that every week tend not to do as well. Again, I don't have concrete data for you. It's all anecdotal. But people who don't come and put the time in every week, it tends to just fall further and further and further and further behind. And then the further you get behind, the more you have to dig out, right? And it just makes it more difficult for you. And then you're stressed out, and then you're unhappy, and then you get upset with me, and then I'm unhappy that you're unhappy with me because it's not fair. And sure. So, all right, awesome.